Welcome back everyone. In this video we're going to talk about transformations of functions and graphs, and we're also going to be doing regressions of said functions when we transform them and when we're looking at graphs. So just starting off, we're going to look at transformations. So as you can see at the top, we're going to be working with this general function equation where we're going to be working with some a value, some b value, some c value, and then some d value. Each of these values are going to represent some sort of transformation of your graph. So I'll zoom out and you can kind of look to see the layout and what each of these transformations is going to represent. So a vertical shift or translation is going to be represented by your d value, which is going to be outside the parentheses. Your c value is going to be indicative of your horizontal transformation, or a horizontal shift rather, and that's going to tell you which way we're going to shift left or right. And then if you look at your a value, if your a or your b value rather is negative, we're going to have a reflection. So if you look at your function, if your a value, which is going to be outside the parentheses, if that value is negative, we're going to have a reflection over the x-axis, which we're going to shorthand as r sub x. And then if you have a negative inside the parentheses, which is going to be with your b value, then we're going to have a reflection over the y-axis, which we will shorthand as r sub y. And then looking down, AP Pre-Cal, we like to use the term dilations rather than a stretch or a shrink. It is going to be important that you do recognize a stretch versus a shrink, but in terms of AP Pre-Cal and their terms of verbiage and what they're going to write, they're going to stick with dilations just to be a little bit more consistent with how everyone across the nation teaches. So kind of diving into the dilations, we are going to break it down a little bit more in terms of a stretch or a shrink. So looking at your a value, if we have our a value out in the front, if that value is bigger than 1, we're going to be pulling it apart vertically, which means it's going to get more narrow. It'll get more skinny or narrow or taller, as some people like to say. And then if we have what we call a vertical shrink, which also we know as a compression, that is going to be when your a value is going to be between 0 and 1. So if your a value is, say, 1/2, 2/3, 3/4, 4/5, anything like that. So then what that tells us is we're going to take our graph and we're going to squish it vertically, and it's going to get more wide. It's going to be pushed out. So now looking down at your horizontal dilations, this is going to be affecting your b value. So your b value, which is inside the parentheses, that's going to tell us we're going to have a horizontal dilation. So if your b value inside is going to be between 0 and 1, that's going to be a horizontal stretch. So we're going to be pulling it apart horizontally. So it's going to get more wide. Whereas if your b value, if it's bigger than 1, then from the sides, we're actually going to be pushing it inwards, and it's going to get more narrow. So hopefully you kind of picked up on some of those keywords I was using when I was describing these. What you may have realized is a vertical stretch is actually graphically going to look the same as a horizontal shrink. And then a vertical shrink is going to look the same graphically as a horizontal stretch. Now, when you are looking at these a and b values, what you do have to be careful about is where those values are in terms of your equation. Where they are in terms of your equation, in terms of the parentheses, is going to dictate what type of transformation it is. So for example, I have this example here for you. So if we have 2x squared, notice how this 2 is going to be outside the parentheses, which is going to make that a vertical stretch. However, if we put that same 2, but we put it inside the parentheses, notice how it becomes your b value, which now it's going to be a horizontal shrink. So we would go from a vertical dilation to a horizontal dilation. So just keep in mind, you've got to pay attention to where those values are in terms of the parentheses. Now down here, down below, this is just kind of another representation of the same data I have above, but it's just another way of looking at it. Me personally, I like this representation here more, just because it's a little bit more structurally organized and not really a list. It's kind of categorized into a specific value, but it's all telling you the same information. It's just a different way of looking at it. So one thing I do want to point out is notice how your b values, your horizontal dilations are going to be written out. So when we're looking at the horizontal dilation, you are going to have to flip it, which I'm going to get more into that in a bit when we do some examples. All right, and then when you are looking at your equation, what you've got to remember, I have it written up here as well, if you have a b value that's not equal to 1, a positive one more specifically, you are going to have to factor it out, and then that's going to impact what your horizontal shift is going to be. So that's what I have down here. If your b value is something other than a positive 1, you have to factor it out first in order to do your horizontal shift. So now looking down here, we're going to kind of get into some practice problems. So this is practice problems where we're also incorporating sketching and graphing, but for the sake of this video and for sake of time, I'm not going to do that. I'm just going to go through the parent function, and then I'm going to list out the transformations. So starting off, we have f of x equals negative x minus 3 squared. So looking at this function, I can see that we're dealing with a quadratic equation, which my parent function of said quadratic is just going to be y equals x squared. So what we're looking at in terms of transformations, we're looking to see how is f of x different than the parent function. We're listing out what's different, and what we list out, those are the transformations. So looking here, what we have is we have a negative out in the front, which that negative, because it's outside the parentheses, that's going to tell us we have a reflection over the x-axis. And then this minus 3 right here, that is inside the parentheses, which tells us that's going to be a horizontal shift, which means we're going to go right 3. Now for AP standards, when it comes to translations or shifts, it could say translate, it could say move, it could say shift, it could say any sort of word that is synonymous with just moving it. So I'm going to stick to the bare basics and layman's terms for this, but just watch the verbiage in AP and be consistent with what the problem is asking. So next over here with number 2, now we have an absolute value graph. So with this one, notice how your value here is inside the quote-unquote parentheses. So your 3, it's not outside, it's going to be inside, which means that this 3 is going to be a b value. So what this tells me is I need to factor out that b value. So I'm going to have the absolute value, factor out that 3, and when I factor it out, I'm going to have x minus 2. And that's going to be inside our absolute value bars. So what we have here, this 3, is going to be a horizontal dilation, but what you've got to remember is whenever we're writing out horizontal dilations, we have to flip it. So rather than saying it's a horizontal dilation of 3, this is actually going to be a horizontal dilation of 1/3. So if you kind of think about it graphically, what's happening with this graph, well actually let's do an absolute value graph, kind of a rough sketch. What's happening to this graph is the x values are actually getting smaller. So even though I'm going to squish it together, your new graph would look something like this. So my new x value is actually going to be getting smaller. We're going to be pushing it in. So it's going to get closer to 0 versus getting bigger. So that's why you have to flip it. Go away, go away, go away. Oh my gosh, go away. There. All right, and then this 2 over here, because we have a minus 2, that tells us we're going to be shifting right. So we're going to go right 2. Now, the way that I kind of remember to flip the x value over here for horizontal dilation and flip the horizontal shift, I always remember it as your x is a dirty liar. Do the opposite of what they say. So I know it's a little raunchy, but you know what? It helps me remember it. It helps some students remember it, so I'm going to stick with it. So now for number 3. So same idea. If you look at your b value with the square root function, we have a -1, so I still got to factor it out because it's got to be a positive 1. So over here, when I factor out that negative, we're going to have 3 square root. Factor out that negative, and we're going to have x minus 4. Let's shorten up that square root. Then minus 2. So when I list out these transformations, so this 3 on the outside is a vertical dilation. So this is going to be v dilation of 3. And then because it's a vertical dilation, you don't have to flip it or anything. And then the negative on the inside of that square root function here is going to tell us that we're going to do a reflection over the y-axis. And then this minus 4 inside the square root, that tells us that we're going to go right 4. And then this minus 2 on the very end, this is your d value, which tells us we're going to shift down 2, or translate down 2, whichever. All right, and then I'm just going to run through this one kind of quick. So, or actually here, let's just do this for sake of time. So the negative out in the front, that's outside the parentheses. That's going to be a reflection over the x-axis. The +4 tells us I'm going to go left 4, since it's addition. We're going to go the opposite. And then the +5 tells me I'm going to go up 5. Who's at my house? All right, and then down here, we're just going to go through some practice problems. So I would say pause here, and I'm going to go through questions 5, 6, 7, 10, and then 14 and 15. So I would say pause here and try those 6 problems on your own. But we're just going to dive right in. So with number 5, this 2 on the outside is going to be a vertical dilation of 2. And then this -5 right here is going to be inside the parentheses, so that tells me I'm going to go right 5. And then this +1 on the very end tells me I'm going to go up 1. So next, so we have a negative on the outside, so this tells me I'm going to do a reflection over x. I have a +1 inside, so that tells me I'm going to go left 1. And then this -4 here tells me I'm going to go down 4. Now, you're totally cool with doing what I'm doing in terms of writing out the transformations. If you want to list them out in like a list view, then that's totally fine. If you want to do what I'm doing with like arrows, that's totally fine. As long as you can write out and communicate the transformations, I'm totally fine. Okay, number 7. So what I do with number 7 is I like to point out this a value on purpose, because a lot of people, when they see a fraction, they assume that it's actually going to be a vertical shrink. But what you've got to pay attention to is if your value is bigger than or less than 1. So in this case, we have 3 halves. So it's going to be a vertical dilation of 3 halves, which is going to translate to being a stretch. So you don't have to mention if it's a stretch or a shrink. You just have to mention if it's going to be a vertical or horizontal dilation. And then you are going to need to list out the factor in which it is being dilated by. And then over here, that +4, so that tells me I'm going to go left 4. So now looking down at number 10. So I have a square root function here. I have a b value that's equal to -2, so I need to factor that out. So that's going to be equal to the square root of -2 parentheses x minus 10 and then +1. So my transformations, I'm going to have that negative on the inside, which is going to tell me a reflection over the y-axis. And then this 2 on the inside, that's a b value, so that's going to be a horizontal dilation. And then you also are going to have to flip it. So that's a horizontal dilation by a factor of 1/2. And then with your -10 here, this is going to be a shift right. I don't know why I wrote shift all of a sudden, but it's fine. And then over here with this +1, that's going to tell me I'm going to go up 1. So now let's jump down to 14. So I created these last 3 problems on this last row, kind of gross and ugly on purpose, just to give you guys some more practice, especially with fractions. So we do have a b value that's not 1, so I got to factor that out. So this is going to be negative parentheses, 1/3, parentheses, x plus 4 divided by 1/3. Now when I divide by that fraction, that's the same as multiplying by its reciprocal. So I'm going to do 4 times 3, which is going to be 12. And that's going to be squared minus 6. Now I can list out my transformations. So that negative out in the very front, that's going to tell me a reflection over x. Then the 1/3 here, that's going to be a horizontal dilation by a factor of 3. So remember, you always got to flip it. And then this +12 right here is going to tell me I'm going to go left 12. And then this -6 at the very end, I'm going to go down 6. And then 15 over here, once again, we have another kind of gross b value. Got to factor it out. So when I factor it out, we're going to have 5 halves, parentheses, x minus 3 over 5 divided by 2. So I'm going to multiply by 2/5. So 3 times 2/5, which is going to be 6/5. And plus 8. Okay, and then we're going to have a horizontal dilation by a factor of, so here's the list view I was talking about. So horizontal dilation of 2/5, and then we're going to go right 6/5, and then we're going to go up 8. So yeah, this is what I meant by a list view earlier. So if you want to do them out with like arrows, or if you want to write them out as a list, I don't really care how you do it. As long as I can find your transformations, we're good. All right, moving on. So now we're going to get into regressions. So with regressions, we're going to be given some sort of graph, and you're going to have to write out what the equation is. And then based on the equation, you're going to be asked to identify transformations. So I'm going to kind of graze through this page kind of quick. I would say pause where you need to if you need to write these down. But one thing I will say is all your dilations were going to be included in your A value. We're not going to do any horizontal dilations for regressions. So we're essentially eliminating the B value. We're just going to kind of cut it out. We're just going to assume your B value is always going to be 1. So once again, all dilations will be accounted for in your A value. So pause as you need, get these down. What I have here are all the C, D values, which are your horizontal and vertical transformations. So these values are going to be referencing your quote-unquote vertex of all these equations. So for this first one, which I don't know why this copied over here like this, that should be a K. So you may recognize the quadratic equation as vertex form. So we're using the vertex as your horizontal and vertical transformations. And then we're going to have some sort of vertical dilation that's going to go along with it. So these are all your different equations that we could be expected to have you do. So we're going to mostly focus on quadratic, absolute value, square root, and cubic. We may throw a rational here and there at you, but it's not going to be a ton of those because we spent so much time on rationals before, or at some point, we're going to have a whole slew of other problems that we want to work on for rationals. So I'm just going to do a couple of these. So now we're going to do the regressions of the equation given the graph. So focusing on this first one, we have a quadratic. So because I have a quadratic, you're going to have to recognize that we're going to use the equation y equals a parentheses x minus c squared plus k. Now, if you want, you could use, whoops, I meant minus c plus d, but if you want to use vertex form and do h and k, the actual letters don't matter. The process is all going to be the same. So just throwing that out there. So looking at your parabola here, you're going to use your vertex for your C and D values. So in this case, your C and D is going to be 5, 2, which is going to represent your maximum. And then what we're going to do is plug them in. So y equals a parentheses x minus 5 squared plus 2. Now, once you plug in some vertex from your graph, then you're going to plug in a given coordinate that's on your equation. Now, we may be nice and we may give you points that it's going to pass through, or you may have to find points on your own. So in this case, we give you 6, -1, but keep in mind you could also use 4, -1, or you could even use 3, -10. So some of these points you can probably go and look for, but I'm just going to stick with 6, -1 for my x and y. That's just me. So when I plug in, we're going to have -1 equals a parentheses, and then 6 minus 5 squared, then plus 2. And then once you plug in your vertex, and then some xy, which is a point on your graph, then you can solve for your a value and determine what your vertical dilation is going to be. So when I get here, I have -1 equals a parentheses. That's going to be 1 squared plus 2. So 1 squared is just 1. So 1 squared, which is 1 times a, is just a. So -1 equals a plus 2, which means when I subtract that 2 over, we're going to get an a value of -3. So when you're ready to plug in for your final equation, you're going to plug in and write your A, C, and your D value in your final equation. So down here, you're going to have y equals -3 parentheses x minus 5 squared plus 2. And then once you have your equation, then you can also identify the corresponding transformations. So based on this, I'm just going to run through them kind of quick. So the negative tells us reflection over x, the 3 tells us vertical dilation of 3, the minus 5 tells us right 5, and then the plus 2 tells us up 2. So I'll let y'all write those over there. Let's do the absolute value. So the absolute value graph here, this tells us I'm going to use the equation y equals a absolute value x minus c absolute value plus d. So your c and your d value is going to be your vertex, which we're going to use the corner point, which is where those two values meet, or rather the two like linear components meet. So your CD is going to be -3, -5. And then the point I'm going to plug in my xy. So I'm just going to do this on top of the graph just to make my life a little easier. So I'm going to start with the equation y equals a absolute value x minus c absolute value plus d. So I'm going to plug in the CD. So y equals a absolute value x minus -3 absolute value plus a -5. So I'm going to clean this up. So y equals a absolute value of x plus 3 and then -5. So now that I have my vertex value plugged in, now I'm going to plug in my xy. So I'm going to have -4 equals a absolute value of -1 plus 3 minus 5. So that's going to give me a -4 equals a absolute value of -1 plus 3, which is absolute value of 2, which is just 2. So I'm going to rewrite this as 2a and then -5. So now I'm going to add the 5 over. So we're going to have 1 equals 2a, divide your 2, which means we're going to have an a value of 1/2. Now with absolute value, another thing I like to kind of watch is your slope. So my slope between these points is also your a value. So that kind of works out nicely. So my final equation here would be 1/2 absolute value x plus 3 minus 5. That's your equation that we're looking for. Now in terms of transformations, we have a vertical dilation of 1/2, shift left 3, and then shift down 5. And then I'll go ahead and do the cubic one down here. So I'm going to skip the rational one because we don't want to focus too much on rationals. So looking at this one, notice how I try to give you less and less on this graph. So your C comma D, your quote-unquote vertex, is going to be your middle point here, which is -4, 5. And then I'm going to plug in the point -6, -1 for my x and my y. So I know I'm going to use the equation. So once again, I'll just do it over here right on top. So y equals a parentheses x minus c cubed, since we're dealing with a cubic, and then plus d. So when I plug in my CD, so we're going to have y equals a parentheses x minus -4, which is going to turn into plus 4, cubed, and then plus 5. And then I'm going to plug in my xy, which I'm going to plug in -6, -1. So -1 equals a parentheses -6 plus 4, cubed plus 5. So -1 equals a parentheses -2 cubed plus 5. So the -2 cubed is going to turn into -8a. So -1 equals -8a plus 5. So I'm going to subtract 5. So we're going to get -6 equals -8a. Divide the -8 on both sides. So we're going to get an a value of -6 over -8, which is going to simplify to a positive 3/4. So my equation here, we're going to have positive 3/4, parentheses, x plus 4 cubed, then plus 5. So when I look at the equation here and I want to list out the transformations, I'm going to have a vertical dilation of 3/4, left 4, and then up 5. Ta-da! All right, so that's it for transforming equations and then doing regressions. Now we're just going to transform individual points. So we're going to kind of do it on even a smaller scale. So these are some really good problems down here. So we're going to first describe the point or the transformation of f, and we're going to suppose that 2, 3 is a point on f of x. So we're going to be transforming the point 2, 3 specifically. So when I look at these points over here, or rather the transformations, I want to transform the point according to this transformation. So this transformation here is going to be a reflection over the y-axis, since it's inside. Now a reflection over the y-axis means I'm going to take some point and I want to move it over here. Now what that means is the x value is going to change. So that reflection tells me I'm going to do a negative x comma y if I were to write out the transformations in terms of coordinates. So if I want to transform the point 2, 3 using a reflection over the y, that's going to transform it to the point negative 2, 3, which is what we want. Now looking at part B, this is going to be a vertical dilation of 2. So what's happening here is I'm going to take my graph, or I guess would be the best way to explain this, and I'm going to stretch it. So it's going to get more narrow. So what's going to happen is your y value is going to get twice as high. So that's going to be affecting your y value. Hence why it's a vertical dilation. So in this case, my transformation, I'm going to leave the x alone, but I'm going to do 2 times the y value. So if I do 2, 3, and then double the y value, that's going to turn to 2, 6. Then over here, part C. So you're going to have multiple transformations. So we want to start off with some kind of baby steps over here, but now we're going to throw multiple at you. So first off, we have a vertical dilation of 3. Which this is going to impact your y value. And then we have a horizontal shift going left 2, which this is going to impact your x value since we're doing a horizontal transformation. And then over here, we're going to go down 4, and then down 4 is going to impact your y value. So if I were to write these out as a coordinate, so I would take my x value and I'm only going to move it left. So moving it left mathematically or algebraically means I'm going to subtract 2. And then for my y value, I'm going to multiply it by 3 and then go down 4. So I would do 3y minus 4. So in terms of the point 2, 3, when I plug in, so 2 minus 2 is going to give me 0. 3 times 3 is going to give me 9 minus 4 is going to give me 5. So here's your transform point. All right, and then part D over here. Now, once again, you have a b value that's not positive 1, so we're going to have to flip it. Or not flip it, but factor it out. So when I factor it out, we're going to have negative f parentheses, negative 2 parentheses x plus 2, and then plus 2. So looking at your transformations here, we're going to have a reflection over the x-axis, but we're also going to have a reflection over the y-axis. And then this 2 right here, that's going to be a horizontal dilation. But what you've got to remember is going to be that it's a factor of 1/2. You've always got to flip that b value. And then the plus 2 inside the parentheses is going to tell us we're going to go left 2. And then the plus 2 on the outside tells us we're going to go up 2. So when you've got 20 billion transformations kind of being thrown at you, I like to categorize them as x and y transformations, kind of like what I did over here. So hopefully, as you remember, any transformations inside the parentheses over here are going to pertain to your x value. So my reflection over y, my horizontal dilation in left 2, that's going to tell me it's an x value transformation. And then my transformations outside the parentheses, so my reflection over the x and up 2, those are going to pertain to my y values. So when I write these out as coordinates, I'm going to have negative 1/2 x minus 2 for my x value, and then a negative y plus 2 for my y value. So when I plug in the points of 2, 3, so we're going to have negative 1/2 times 2, which is going to be a negative 1 minus 2, and then negative 3 plus 2. So your final coordinate here, we're looking at negative 3, negative 1. Ta-da! So I would definitely recommend going and doing problems like 24. It's the same idea as number 21 here. It's just on a bigger scale. So you're going to have to write out your points individually. So for example, 1, 2, negative 3, 0. then -2, 1, then -1, -2, 0, 0, 1, -1, and 2, 2. And then you're going to apply the transformation to all those points, and then you're going to rewrite out what the new function is going to be. And then based on that, then we're going to write out what's the new domain and range of your transform function. So same idea over here. Luckily, I decided to be a nice person, just use the same graph. So those points are transferable over here, and then you can just make the necessary transformations. So make good choices.